All right, cool. Here we go. Conjugates. What are conjugates, guys? You guys remember? You guys kind of have an idea, but just don't remember how to say it? Okay. Conjugate is kind of like, I don't want to say, please don't say it's the opposite of something, because the opposite means you put a negative in front and you change all the signs. In a conjugate, the only thing that changes is the sign in the middle. So, the conjugate of 3 plus 4x would be 3 minus 4x. That is the conjugate. The conjugate of a plus 2i would be a minus 2i. The conjugate of negative x plus radical 3 would be negative x minus radical 3. Notice I didn't change that x to a positive. Okay, that would be the opposite, lady, but not the conjugate. What's the conjugate of 6 minus radical 2? 6 plus radical 2. And finally?
Negative 5 plus radical 2.
Absolutely. So, you guys good with conjugates? Yeah. All right. Now, what makes conjugates special? Do you guys remember? What happens when you FOIL them out? What does? The middle part does. Okay? Let me show you what I mean. Let's say we had x plus 2 and x minus 3. Obviously, those are not conjugates, right? Obviously. If I FOIL this out, this would give me x squared. This outside would be negative 3 plus 2 would give me a negative x. And finally, I would get negative 6, right? See how there's a middle part here? Conjugates, that middle part goes away. It goes away. Let me show you. Someone give me a set of conjugates. Make it easy, please.
2 and 6. 1 and 1.
How about 6? Conjugates are going to be the same, except what changes? The sign in the middle. That's the only thing that changes, okay? So thank you. So let's see. I've got two conjugates. Check this out. X times x is x squared, right? And here's what I mean by the middle part. What is x times 6? 6x. And negative 6 times x? Negative 6x. So what's 6x minus 6x? Nothing. It's gone. It always happens. And then we get finally the last part, which is negative 36. So conjugates have that special property. The middle term always falls out. Okay? So, important thing to know there. We've already started talking about some of these things, the essential understanding. We're talking about factors and how to find those without someone giving us a possible option, right? We have to find them ourselves. And then we talked about a couple of things that we're going to start doing today. We did the rational root theorem Thursday. Today we'll be talking about the conjugate theorem, and we'll be talking about Descartes' role of signs. So let's get to it. We already did those, finding the possibles. Here we go. Using the conjugate root theorem to identify roots. The conjugate root theorem kind of says two things here. And we'll get, so let's talk about this. Let's see here. I lost what I wanted to say. We're finding rational roots, correct? At the very beginning of this section. Rational roots was simply all of the factors of p over the factors of q, correct? And that will give me a bunch of possible choices. Now, here's the deal. Let's say, remember how we always found, oh, there was one problem where we only found one root, correct? And we said the other two would have to be imaginary, correct? Those are not rational roots. Those are not rational. Okay? The first thing that we did, all the p's over all the q's gives us all possible rational roots. Sometimes we're going to get things that are called irrational. Someone have an example of an irrational? How about square root of 2? Yeah. Nice job. Square root of 2 is irrational. Good job. And then we have these other numbers called imaginary. We'll say something like, I don't know, let's make it fancy. X plus, or sorry, x minus I. That's imaginary, right? Or sorry, I should say complex. Correct? We good with that? Here's what the conjugate root theorem says. If one of the roots happens to be irrational, or if you have roots that are imaginary, you need to know that they always come in conjugate pairs. They always come in what? Conjugate pairs. So if radical 2 is one of the roots, what else should be one of the roots? Negative radical 2. Nice job. That's, I don't know what I was going to write. A negative radical 2 should also be the root because they come in conjugate pairs. if I did have x minus I as one of the roots, then what else should be a root? X plus I, absolutely. Okay? So that's what the conjugate root theorem says. If you have roots that are irrational or imaginary, they always come in conjugate pairs. So if they give you one of them, they really gave you two of them. Is that true for rational roots? That is not true for rational roots. That is only true for irrational and complex or imaginary. Okay? So, let's go about how. This is saying you've got some polynomial. One of the roots is radical 2, and another one is 1 plus I. What are the other two roots? Negative square root of 2 and 1 minus I. That's not big enough, but make sense? And there's all four roots. So they gave you two, they really gave you all of them, right? Okay, cool. Questions on this slide? Can I change the slide?
Wait, that's all you gotta do?
Well, that was the question. They said, what are the other two roots? Of course, that's not going to be all that we get to do, but you understand what's happening, right? We're okay? Thanks for ruining my moment, Munoz. Sorry. Okay. This says, hey, you've got a polynomial p of x, and 3 minus 2i is one of the roots, and so is 5 halves. What are the other roots? 3 plus 2i and negative 5 over 2? No!
Negative 2 over 5.
Negative 2 over 5? Sorry.
Because there's 2. You know what? I think that's so good.
This is why we're talking about this. I want you to be careful. Is this irrational? Is it complex? So can I use the conjugate root theorem? No. I cannot be sure. I cannot be certain that the opposite of this happens as well as a root. I can if it's a complex or irrational, right? Isn't that what we said? Only irrational or an imaginary, I should say, slash complex. Only those come in conjugate pairs. Now, 5 over 2, that's rational. So I can't say this about it. Does that make sense? Top one? No? I will. I'm going to go ahead. All right. Now, since we can find the roots, we're going to have to be able to construct a polynomial. Okay, and we've already constructed polynomials from the roots, so it's not a big deal. All they're having us do really is use the conjugate root theorem and then do our happy math to find the actual polynomial. So let's start here. Let me make this a little bit bigger so you guys can see that. Before I do that. Okay, so this is saying some polynomial has a root of negative 4 and a root of 2i. So they want me to construct the polynomial. Okay? Here's what I know. I know that x equals negative 4. I know x equals 2i. Is that all I know? No. What else do I know? X equals negative 2i also. Why does x equal negative 2i? Because this is complex or imaginary, if you want to call it that. Therefore, it should happen in conjugate pairs, so I should get negative 2i. How about positive 4? Should I get positive 4 as well? Not necessarily, because that's not irrational, nor is it complex slash imaginary. Okay? So, I've got those three. I'm going to turn them into linear factors. That means that x plus 4 equals 0. X minus 2i equals 0. X plus 2i equals 0. That means that all my linear factors are x plus 4, x minus 2i, x plus 2i, that equals 0. And all I need to do at this point is to expand it. I'm going to start by multiplying the conjugates. because that's going to give me x squared plus 4. I took a big shortcut there. Anybody got questions there? Okay, and then I got to multiply that by x plus 4 here. That equals 0. So here's what I've got. I've got x cubed, and then I've got plus 4x squared, and then 16. What's my last step? What's it called? Standard form. What does it mean? Someone said it back there. Put them in order from highest to lowest. What is that? That's descending, right? That's descending. Cool beans. Cool? No? Did I still write it wrong again? Oh. Ah, thank you. I see it. I see it. My bad. Thank you. You're looking out. Yeah. By what? That's what I asked about earlier. I just foiled this. Now, they're conjugates, right? So, because it's right there. Well, I did these two first. That's how I got this. And then I did the x plus 4. Here, I'll do this. We're good? Change slide? No? Your bicep? It's the funniest thing I've ever heard. Someone said they tore their meniscus. I just thought it sounded really funny.
It's so hard in your knee.
Is it in your knee? Your meniscus. Oh, dear. Yeah, the highest degree. The coefficient doesn't matter. Okay. All right, cool. Questions on the conjugate root theorem? Can I change slides? All right. Do we need to do it again one more time? Or are you guys good? We're good? One more? Here it is. Find me the polynomial then that has these roots. Find me the polynomial that has these roots. This is. Pineapple? Can pineapple apple pen? There's something? Is it butterfly or is it fly fly? Butterfly. Don't worry, I'll be. Why does it sound positive? Whatever order you want. And that's my favorite word. Infinitesimal. Infinitesimal. Yeah, that's why it's my favorite word. Kind of like, infinite's so huge. Infinitesimal means it's just so tiny. Huh? Yeah. It's just very, very small. Peoples? Oh, my peoples. What's up, my peoples? You guys get to there? Is this x squared plus 6? No. Is that right there, guys? X squared, that's x squared, negative 2x, negative 3ix. Forgot that. Let's start. Let's go here. That's negative 2x. That is a positive 4. This is negative 6i. And then finally, positive 3ix. That would give me minus 6i. and then minus 9i squared. So let's see here. That's gone. That should, wait a minute, 6i, that should be gone too. Why didn't it go away? This one should be positive. So that's gone. So we got x squared minus 4x plus 4 plus 9. X squared minus 4x plus 11. Right? And then we got to multiply that by the other two, which is x squared minus 10x plus 16. So here we go. I hope that's right. Times x minus 10x plus 16. Let's multiply this old school. Oh yeah. What's 16 times 11? 16 times 11 is 176. Positive. 16 times 4 is negative 64x, and then 16x squared. 0 for place value. Let's go to the next one. That's going to be what? Negative 110x. And this should be positive 40x squared and negative 10x to the third. Right? I need some space. Okay, 2 zeros for place value now. Now we're going x squared, so this should be a positive 11x squared. That should be negative 4x to the third. And then we should get positive x to the fourth. Let's add them up. You hadn't seen that? Dude, the classics, man. They never go out of style. X to the fourth minus 14x to the third plus 54x squared minus 174x plus 176. Ooh, drop the mic on that. How do we get what? I added them all. Oh, I missed one, didn't I? I missed.
Even if you did miss it,
What should it be?
like if you missed a
Oh, 51, 61, 67. Is that right? Okay. Is that the only one? 174, yeah. Yeah, I totally missed that one, didn't I? Ah. And I had it wrong. All right. Okay, gotta get to the next part. Thank you. Need to do this last part. This is called, did you still need that? Sorry, I didn't hear you.
Yes.
I'm sorry. I check. I can chill. Oh yeah.
Wow, now I can barely see that.
What do you need, the bottom part?
No, I just need the middle.
Can you see that okay? All right.
Just write down a different because that's a lot of work. I distributed all. And I try to keep everything.
The last two, I just stacked them. Yeah, see, so these two got boiled out, and that gave me this. And then I multiplied those two and just stacked them. Unfortunately, you can't do that with the first one because they don't have place value that lines them up. So it's just kind of all over the place. Everybody's telling about their computers today, guys. Just put them in Arizona time. Go into settings, time zone. Settings, time zone. It should never change again. Do you realize that there are more than 3,000 kids here?
No, but like when you set up computers, like the systems that go.
No, all they can do is push stuff out.
I lost
might have done some. Lost what? Oh no. Is that a phone? That's not a phone. That can't be a phone. Because there's no phones allowed right now. Right? That can't be a phone. Because there's no phones allowed. Shouldn't have that. Like, I believe that you're not using it, but if you have a phone out, then the person that is using it, they're like, look at all these phones. You ain't saying nothing to them. So it's everybody or nobody. That's the first thing I always get. Or if I'm like, hey, can you be quiet, please? You're being very loud. Everybody else is talking. I got to do one at a time. Right? That's everybody's first defense. You ain't telling nobody else to be quiet? Why are you telling me? Uh-huh. This? Let me. Does that help? Alright, we're good? We're good. I'm changing it. Brown? Okay. This is a cool trick. I don't want to say it's a trick. That's not true. It's actually a rule. Guess who made it? Descartes. Descartes, famous mathematician, Descartes. This is called Descartes' rule of signs. Do you guys remember when we were finding all the possible roots? It's like, oh, you got to go positive, plus minus 1, plus minus 2, plus minus 3 over 5. And there was a lot of them, wasn't there? So it's like, God, man, do I really want to sit there and sift through all of them? Well, first you need to know how to find them all. But you also have to know how to be selective about what you want to use. So, this is Descartes' rule of signs. Let me go ahead and go to the top here. I've got x to the third minus x squared plus 1 is equal to 0, correct? And this is very simple rule that you're going to hopefully like. Let's first figure out how many of those roots are positive. Like, how many roots should I get here, max? I should get 3 of them, right? Wouldn't it be nice to know how many of them were positive and how many were negative? Well, let's see here. Yeah, sure. I'll tell you why it matters. Let's figure out how many positives there are, okay? Here's my function, or let me change it into a function. I'll call it p of x. Get it? Polynomial? No? All right. Okay, so the first one's positive, right? Yeah. And the second term is negative? Yeah. Did that change signs? Yes. I'm going to put one sign change in there. From negative x to positive 1, did it change signs? Yeah. Yes, it did. How many positive roots will I get? 2 of them. 2 of them. Let's go over to the polynomial again. P of x is equal to x to the third minus x squared plus 1. I know now that 2 roots are positive. That's a big bonus, isn't it? How do you find the negative roots? Well, I'm going to change this positive x for a negative x. And that will make this negative x to the third minus negative x squared plus 1. If I expand this, that's still going to be negative x to the third. This would become a negative x squared, and this would be plus 1. So this now, my friends, is p of negative x. And it will tell me how many roots are negative. Is there a sign change from the first to the second? No. What? Shh, I can't hear your question. What's negative times a negative? Positive, right? And then positive times another negative makes it negative. Who's still confused? Okay, from the first to the second, we had no sign change, but from the second to the third, we did have one sign change. That means that I have one root being negative and the other 2 being positive. So I've got this whole list of roots, and I find one that's negative from this one. Should I keep testing more negative roots? No. And that test only takes about a few seconds, doesn't it? So that's why it's very helpful. because it's steps, baby steps, right? Baby steps, little by little. You guys understand the Descartes' rule of signs? Questions? All you're really looking for is, did it change? Did it change? Did it change? Did it change? Cool beans? Good. I hope you thought about that. You know you're going to get a brain freeze. Right?
Go spit it out. Go. Hurry up.
I can beat this. I can beat this.
Ice.
Ice,
Like
baby.
2 big old pieces of ice in the mouth. Like it's not that big.
All right, are we good?
Those might be, but it's not your mouth.
Good. All right, figure out how many roots are positive, how many are negative. How many roots are positive, how many are negative? If it changes from one to the next, then it's one. It's yeah. Put it in the one. You put it as a one change. Here, you could do this. Did it change? Yeah, so that's 1. Did it change? So that makes it 2 root. Did it change? So that makes it 3. So 3 of your roots are going to be positive, which means one of them is going to be negative. If you want to run a test to check it, you can. All the x's, yeah. So, let's say you were going to do p of negative x. You would have 2 fourth to the third plus 3 times x squared minus 1. And then here you put all the negative x's in there. So this would become, that's still positive, so that's still 2x to the 4th. That would be negative, right? 3 of them, and then one more makes it positive again. So it'd be positive x to the 3rd. This would become positive 3x, and then minus 1. No change, 1 change. So one of them is negative. But once I find my one negative root, should I keep testing negative roots? Don't waste your time. And I think if I did tell you earlier, you probably wouldn't appreciate it as much as you do now. Right? Touche. Question? Stretching. What's your sweater say? Under. Oh. I thought it was like aviators. I don't know why.
She thought I said Uber.
Uber? Nice. Under Uber. Hey, that's. At least mine started with an A and then with an R. Aviator. Alrighty, there's no questions. That's all I've got.